So Nathan's posted this question on the forum, and it's regarding tricky low mark exam 2 type questions. And I know exactly what he's talking about. As soon as I saw this forum post, I really wanted to answer this question because these ones are the ones that sneak up on people. And it's really because when they have exam 2 type questions, they're long questions that might be worth 12 to 15 marks on average. And they're all split up into multiple components, and multiple components can seem extremely hard, and they're only worth 1 or 2 marks. But the problem is that they might be earlier in the question, therefore meaning that you have a lot of questions that you can't answer because you're relying on the answers from the first parts. So it's really important to get those ones right. And if you do struggle, hopefully it is going to be on the later questions in the in that part, or like the later parts of that question, just to ensure that it doesn't affect too many future responses. So Nathan says, I always see these 1 or 2 markers that seem so much more difficult than those big markers in every exam too. Could you make a video on how to tackle them? So I've chosen an example, which I'll go through in a bit. But first of all, I'm going to, just preface by saying that the exam 2 is not meant to be easy. There are meant to be difficult questions, and these 1 or 2 markers are the ones that, really sneak up on people. And if you look at the exam reports, you'll see that the percentage of people that got them right are usually very low. It could be as low as 1% to 2% for some questions. So on average, it would be like 1 to 5% of people get full marks for these types of questions on the upper end. So it's just you can't expect to get them all. That's what I'm going to say first off. So if you can't get them all, that's okay. You just want to increase the percentage that you do get to kind of maximize your knowledge. So if you look at past exam 2s from memory, if you get a 70 out of 80, that's pretty good. You're on track to get, like pretty much guaranteed 40, obviously depending on your other assessments. But if you get 70 out of 80, usually you're in the 40 plus range. And it depends on your year as well. It depends on the difficulty of your exam. So there's no specific trick to be able to do these questions, right? It's just a matter of having the knowledge and having the experience to do them. And I'll give you an example of one that maybe even after I finished year 12, I probably wouldn't be able to answer this question. But as teaching for 6 years now, I've been able to expose myself to lots of types of questions. So I feel like if I see any question, I might not be able to get it perfectly right every single time, but I'll be able to see a question and know pretty much that's the strategy for answering that question. And here's a perfect example of one. And it's one of those questions. Do you ever get those questions, Nathan, where you would be like, oh, if I saw that exact type of question again, or if I saw that similar concept again, I'll be able to get it. You have to have that mindset for all types of questions. So even if it seems extremely difficult, you have to imagine that, if you got a question that's kind of framed in a similar way, or the same concept is framed in a different way, you should have the confidence to be able to answer it once you've gone through it. And that comes through not only practicing, but also reflecting about how you did. So whenever you get a question wrong, especially from an exam, you have to actually, what I recommend is that you answer the question again fully, without looking at the solutions, like while you're doing it again. So let's say if you do a test and you get 60%, right? And there's 3 questions that you got wrong. Like let's say 3 long questions because it's an exam 2. You need to, look at the solutions and say, oh, that's how you do it. And it should be an or moment. It should be, oh, that makes so much sense. It shouldn't be, oh, I'm still kind of confused by that. You should be able to read the solutions and see exactly how to do it. And if you can't read the solutions and get that or moment, that realization, then it's maybe because you haven't understood the theory well enough. So then you have to take a step backwards and go backwards in the process. And it's fine to go backwards. You go back and you realize, okay, this is what I'm missing from the theory. You refine the theory, then you move to the level up, which is applications. Then you get that or moment, that realization. Now I know how to do it looking at the solutions. And then you do the question again from scratch without looking at the solutions while you're actually writing it. And then that will allow you to actually go through the process of saying, okay, this is how the solutions had it. Now I'm going to try that exact process and see, how I would do this. Because if you look at solutions to something, it's not always the same process. I said in the previous video or in another video that the name of the subject is VCE Methods. It's about the method, but the method is not always the same for everything. There's multiple ways of doing all of our questions. If you just take a basic question like this one, x squared minus 6x plus 8 is equal to 0. Solve for our solution for x. Most people would see this and they would factorize it. X minus 2 outside of x minus 4 is equal to 0 and get solutions from that. But you could also technically complete the square and then rearrange for x. Or you could use the quadratic formula to find your solution. There's there's so many ways of doing the same question. So it's not necessarily about, doing the right way. It's just about doing the way that works for you. And the way that works for you is different compared to the next person. So just make sure that when you retry these questions, you do it in your own way that you're comfortable with. And that's why I say don't look at the solutions when you do them. Look at the solutions to mark your test and then reflect on what you did wrong and then retry that exact question from scratch. And it might seem a bit tedious to do at first, but trust me, it pays dividends. Just trust me. Just do it once and you realize I learned so much more rather than just looking at the solutions and say, okay, that's what I did wrong. Okay, it's good to know what you did wrong and good to know how to do it, but it's different actually going through the process and writing it all out. That is a whole different type of learning that a lot of people don't appreciate, and it's such an untapped way of actually learning. And it's actually how I learned most of my skills as well. I wasn't necessarily from just knowing everything straight away, because I say this story all the time, but when I did my first exam 1, I got in the 60s, but I was acing my SACs. And it's because I hadn't specifically prepared for prepared for exams. I was just specifically preparing for SACs for that specific content, but I never actually sat through an exam and tried those questions out. So that's why it was a shock for me. So to refine that and to perfect my exam 1 and my exam 2 skills, I had to actually go through the solutions and then retry those questions that I did wrong. And that was the best way of learning. My scores exponentially increased after that with just a few exams after that, I was getting, consistently in the 90s. So that's where kind of your knowledge needs to be. And the only way of getting there is just accept what you do wrong and try it again. And yeah, it is humbling at first because you tried the question again and then you know how to do it because you looked at the solutions, but then it's a whole different thing, actually going through it again. That's what I would say to that question. But let's just have a look at this one. I've kind of given it away with this here. Let's just rub it out so I can explain how I actually got that. But in this example, we have g of x is equal to 2 to the power of x plus 5. State the value of the limit of g of x when x approaches negative infinity. This wasn't that part of the question. This is just part A. I'll just do it. Negative infinity, the graph is going to look something like this with an asymptote at 5. It goes upwards in the positive direction. So the limit as x approaches negative infinity approaches the asymptote value of y is equal to 5. So this is just going to be equal to 5. That one's fairly easy. Now, the derivative g dash of x can be expressed in the form g dash of x is equal to k multiplied by 2 to the power of x. Find the real number k. So the trick, this is a pretty hard question, I'll admit. I'm not sure how many got this right because I hadn't looked at the exam solutions or the examination report. But straight away, I see this question and I think to myself, you cannot derive 2 to the power of x in its current form. You need to change the form to something that is actually derivable, or you can find the derivative of. There's no verb for deriving, I don't think, but you should be able to convert this into a form that you actually can divide. And even though this is a calculator type question, let's just do it by hand because it's more interesting this way because I want to go through the process. But straight away, I see this question and I'm just going to preface it's purely through experience. I know what to do in this one, but you don't have the experience yet. So I wouldn't expect you to get this question straight away. But if you got a similar type of question in your next exam or your next SAC, I would be expecting you to get it because you're going to work through this question and you're going to see the exact thought process that I go through and you're going to develop your own thought process from that. So we have 2 to the power of x plus 5. So straight away, I'm thinking I need to convert this to an exponential base or a natural base, which is e. And that's because I actually know the derivative of e to the power of x. It's just e to the power of x. And I know the derivative if I have e to the power of ax as well, if I have a coefficient at the front. So what I'm thinking is, how do I convert 2x to e to the power of x? And that might be something that you don't know. And that's actually fine. But what I want to emphasize is the fact that I'm thinking that I want to convert 2 to the power of x to e to the power of x. That's actually the main thing that you should pick up because that thought process is really valuable. And then it's just a matter of figuring out how to do it. Figuring out how to do it is just like you just exposed to it once and you know how to do it again. But if you have the thought process of, how do I convert this to a natural base? That is like, if a student said that and weren't able to do the algebra, I would think that that student is amazing. Even though they weren't able to do the algebra, they had the thought process because that thought process is replicatable to any type of question. So 2 to the power of x to e to the power of x is my problem. How do I do that? If you realize that, if you have that realization and you have that thought process, then hopefully you did when you're looking at this question. If you didn't, it's fine because this is a later topic anyway. Most exam 2 type questions are for later topics, so I didn't have that luxury of choice. Now, what I'm going to say straight away is that if I want to convert e to the power of x to 2 to the power of x or something along those lines, how I represent 2 to the power of x is as e to the power of log e2 multiplied by x. Now, the reason why this works is because the exponential and a log cancel out. It's almost the same as like if you have a squared of a square root, they'll cancel out as well. So this is actually 2 to the power of x is equivalent to e to the power of log e of 2 multiplied by x. So, I mean, it would be the same as if you had 2 is equal to e to the power of log e of 2. You could just imagine that the e and the log e cancel out, so you're just left with 2. And I've just added the x to the power there. So that's why it might be a bit confusing. But hopefully this makes sense. Sweet. Now I can rewrite 2 to the power of x plus 5 as that. So I can rewrite this as e to the power of log base e of 2x plus 5. And this I can actually find the derivative of because I have it in the form e to the power of ax plus 5. And I know the derivative of this, you just multiply the a to the outside, so it becomes ae to the power of ax. And then the 5 is constant, doesn't affect our derivative. So if I want to find my derivative, g dash of x, that's just going to be equal to log base e of 2 multiplied by e to the power of log base e of 2x. Okay? But I need to get it back into this form here. So I'm going to say that this is equal to log base e of 2 multiplied by this becomes 2 to the power of x again. And this is kind of analogous to k to the power of k multiplied by 2 to the power of x. So you can see my k is equal to log base e of 2. I'm sure if you had a calculator, you can do this in one step. But that's okay. But you can see that just based on my thought process, I can kind of figure out the algebra after that. So how do I explain? How do I say? This is a key step here. If you can figure out that we need to somehow get from 2 to the power of x to e to the power of x, that's perfect. And that purely comes from the fact that you have to know what functions you can derive. So this whole thought process is, okay, I need to be able to derive this. Therefore, I need to be able to convert it in that form. And that form is the natural base form. So how do I do that? That should be the flow of your thought process. And that's what you need to train. And then the math comes after that. The algebra comes after that. So hopefully that makes sense for this specific question, but hopefully it makes sense in general as well. And hopefully, yeah, I gave decent revision tips for you, Nathan. So yeah, I always see 1 or 2 markers. So those 1 or 2 markers are meant to be difficult. Don't gauge the difficulty based off the amount of marks because it's not always the same. Base the difficulty off whatever you want. Usually later in questions, so later parts in questions, they would usually be harder. So, if you can't get it, it's not the end of the world. Skip it, come back later. That would be my advice. But when you're going through, just a quick summary of what I said. So the point 1 is if you do practice tests or SACs and you can't get a question, look at the solution and realize what you did wrong and then redo it from scratch without looking at the solution. That would be point 1. And point 2 is refine your thought process when you see questions. So kind of work through it step by step. If I see the 2 to the power of x, I need to derive it. How do I derive it? I need to convert it to an exponential base or convert it to a natural base. So refine that thought process and then the algebra comes later. So best of luck with that, Nathan, with your exam revision.